Hi everyone, my name's Hayden. I just wanted to show a presentation of some project I found and then did and show you what it's about. I found someone posted on LinkedIn about it and I went to Udemy and found it, and here it is. It's just a 3-tier web application, or 2-tier technically, because it has an app server and then a database. Doesn't really have the middle layer. So just to start off, in Lucidchart, the project's called Lift and Shift. So it's just taking a on-prem solution to AWS with user data scripts. So I just skipped to the AWS part because that's what I was interested in. Let me just pause my video to add cursor highlighter. Just because this is my first time presenting with audio. Normally I just do a YouTube video and it's no audio. So just testing this out. So this will be fun. The first diagram I wanted to create was a conceptual one of the project. This one is good for non-technical folks and multiple levels of business users. So it's just a simple user going through a load balance in AWS to an app server or multiple, which is a Tomcat server. So that's the front end. And then the back end is a bunch of databases. So it's really simple. It's really conceptual. Managers, executives can really just basically see what it does and sort of how. Now, the logical one is more in depth. I'm just using my laptop screen instead of my curved monitor, just because I don't want to play around with the resolution too much. And here I can be clear that you can see depending on if you're a small or a larger screen. So to start off, the users are going to go through to the website, which is hosted in Route 53. The AWS account should not include the users, obviously. They're all public users, so we're just going to move that over. From Route 53, they're going to go to an application load balancer as shown in the conceptual diagram. And then from that, the app load balancer is going to forward it to our app servers on port 8080. And then the app server can connect to the backend systems, which is a EC2 instance with MySQL, another instance with memcache, and a rabbitMQ one. So this is a bit insecure, or a very basic way to do this, because we're running a default VPC in the default subnet. So technically all these systems and subnets, security groups, have internet. So it's not like a private or public subnet. If you were going to properly do this in production, the backend servers would be in a private subnet and the other two would be in a public subnet, and you'd be pretty good to go. But you would also need a NAT gateway so these servers can actually have outbound access to the internet in order to update the servers if you need to. If you're not doing the CI/CD platform with a gold image where you update that, then push it through. That's a lot of information, sorry. The cool bit here is that the Route 53, I worked in AWS Certificate Manager to create a certificate, which then provides encryption for the application. And then what was new for me was working with the app.war file, which is just a Tomcat web application file, and it extrapolates that to be your application, is my assumption. I don't have much developer experience, mostly on the architecture side, so this was a good one to play around with. And the auto scaling group, I just did a simple max of 2, desired 1, minimum 1, so there's always one up, and that there's a health check port on 8080. So very simply just runs through into our AWS account from the users, straight through everything to the app, and then the app can pull from the MySQL, the database. So we're just going to jump to the web application. All right, so from here you can see the web application. I just have it on hades.jazidahades.link because it was the cheapest URL to buy through Amazon Route 53. And the password is just default admin_VP. And you log in. Thanks, LastPass. No, we don't want that. All right, I had trouble logging in because I had both the security group system, scaling group system up, and the original, so I wasn't sure which way to route or which database to actually connect to. So we can see this is Visual Pass website. If we go to all users, we can list users, and the admin VP, we can see that data is from the cache, which is memcache, which is really cool. And then if we go back and we go to rabbitMQ, we just see that we're MQ created some connections in the queue, which is nice and easy. So if we go back to the users and I disable or turn off the memcache server, you'll see that this takes really ages. So the memcache server I've actually stopped, and it still accesses the database, but it takes forever. So if we hold like 30 seconds, 20 seconds, I might pause the video after a bit because it might be too long, but we'll see. As it still loads, it just won't be cached and won't be accessible very quickly. So I had to pause it for a little bit, but as you can see, it's not pulling from the mcached server, but it is giving us the user information. It just takes a lot longer. So mcached is for making high-avail websites quicker, or dynamically loading websites, and that way it runs faster. So I'm just going to show that each C2 instances now. We have the rabbitMQ server. It's running the application server, which was the original one created before this the scaling group. So I've turned that off to stop it interfering with the security group. And I'll turn the memcache server on because we can SH into it and just check the user data. But ultimately, it's just 3 apps in the same default VPC and subnet. It's pretty cool that way, nice and simple. I'm just going to SSH into the app server, which will be the security group one, security AWS auto scaling group. I always get those mixed up. So if I just bring it here, you can see that I was playing with it before. CentOS user is for the database servers. The app one is different. Yes. Cool. And I actually had to install Tomcat 9 DevOps. The project that we used Tomcat 8, but it's not available in Ubuntu as easy. So I built the application root.war, and then I moved it into the web apps folder, and then you can see it here. And then when you run Tomcat, it extrapolates it, unzips it into the root directory. And from there, you can sort of see, I'll just go root for now. And you can see how it's configured. So you go webinf and then classes. And if I cat the application properties, you can see the MySQL configuration with the driver. And then I've just done connect MySQL, telling the application to connect to the database server on the hades.in, which is the domain I created for an internal hosted domain, which I'll show in a bit. The username and password, this is really bad. It's obviously in clear text in the file itself, the configuration, so that's bad. The memcache server was mc01.hades.in. The rabbitMQ was rmq01, and they're able to find each other. So if I telnet to, I think it was db01.hades.in, and the port from MySQL, you can actually see it connects. So it's actually allowed through, which is really cool. The reason we have done internal hosted zone is just so that if these IP addresses ever change, we don't have to rebuild the application and change the IP address. And that's probably a good spot to jump to the certificate manager, or sorry, the hosted zone, and then I'll show the certificate manager. So if we go to Route 53, you'll see my 2 domains probably. I have 4 hosted zones, so I was just trying the original way, which is with vProfile through the Udemy course. But with hades.in, I've just added some alias records, some A records, and you can see that the database server 01.hades.in points to the IP address, the private or internal IP address of the database server. And then it's just a type A record, which routes traffic to an IPv4 address or some AWS resource directly. And it's just a simple routing policy. Like, this is all really simple. And so if you ever were to change the private IP address or have a auto scaling group with a load balancer, you could change the IP addresses here instead of going to the application itself and then having to rebuild it each and every time, because we want as minimal manual input as possible for maintenance and changing things. So again, rabbitMQ server, you can see it just points to that. And yeah, it's pretty cool that way. The way we did the certificate manager, so I just had a hosted name with my wife that we're using for another course, and I had jazidahayes.link. So what I did was I made a for the certificate manager, which is for SSL and all of that for port 443 and stuff, and make it encrypted. In AWS, the certificate manager, you have to actually add the value of the certificate so that AWS can authorize it and trust it and prove it's actually from them. And then what I did was I created a alias record. You can see record A, and it points to the actual load balancer URL. So I did a subdomain of hayes.jazidahayes.link, which is points to the load balancer, which is pretty cool that way. And then the certificate manager, which was really interesting to work in with AWS because it's not too easy. It is once you read the instructions and all, but it's not self-explanatory. So you request a certificate, and this will say like pending. The status will be pending. And then in here, you'll add the domain. It gives you a CNAME and a value. And these are what you put in your CNAME record and value in Route 53 for your DNS settings, which is pretty cool. So I really like that idea of doing it that way. So what I did forget to show was the user data that we was launched. So if we just curl the AWS IP address from the instance, it'll actually show what it can. And this one doesn't have it because it was an AMI image which had everything already installed. So I'm just going to log into a database server instead. So I've just quickly logged on to the database server, and then if I curl the URL again, it shows you everything that was used. I'll probably do more here so it's easier. So we're just doing the database password again as admin123, updating the server, installing zip and unzip in the MariaDB server, which is MySQL really on Ubuntu, CentOS. And then we're starting it and enabling it, and then we're creating a user, we're deleting the standard user and all of that. And if we go down more, we can see that we create a database accounts, and we grant all the privileges to the local host, and then we flush privileges to refresh it all. And then we enable firewalls and active zones for MySQL. So it's pretty cool that way. But it's just simple that the servers were installed with user data scripts. We then connected them up with security groups, and that way, I should show the security groups. So if we go to EC2, we go down, even click the database one, go security groups. Then you can see here what I did for cheating was I added my own IP address just so I could SSH in at the time to make sure things were working. You can delete that for like production access. And then you have allowing the Tomcat server to connect to memcache on 112.1.1. And then you can allow Tomcat to connect on 5.6.7.2. And each security group really is attached to the relevant hosts. The load balancer is really interesting, actually, from a basic point of view, because it has two listeners, port 80 and port 443, but the port 80 one you can really just cancel if need, delete, because really it should only be running on 443. So I've just had my Hayes profile production elastic load balancer here. And so I have 443 and 80 open, and they're pointing to a target group, which really is just the app server that I was pointing to. Yeah, and there's two registers targets. So that's the original one you make to make sure everything's working, and I turned it off. And then this is the scaling group, the duplicate here. So it's pretty cool. One is healthy and it looks good there. And it's just quite simple that the load balancer is then forwarding traffic to port 8080. It's pretty cool that way. And then the to do auto scaling, I just have an auto scaling group, which is lift and shift, because that's the name of the project. If I can scroll up. So I just had a desired capacity 1, a minimum of 2, and a max of minimum capacity 1 and a maximum of 2. And if I delete the server, it reboots up, which is pretty cool. I'm not sure if it shows the target group here. It has the security groups that it's popping the machines into, which again is the app server. is just that one. E18, the selected one, which is the application security group. So it puts it in the right security group, ready for the load balancer to shoot traffic to it. And I'm not sure if here I can find it, but if I go on to launch configuration, I also named it lift and shift. Can I show it here? Yeah, it's just the AMI that I created from the original app server. And then it has a profile to download the application folder from S3, which is pretty cool. And then it uses my name, the DevOps project, for this one, which I'll delete soon. And yeah, it's just a copy of the app server. So I think it's pretty simple. But most of the learning was the certificate manager route 53. I think that was pretty fun. But I just wanted to try something. The next one's going to be on doing this in a continuous integration type way, because using the user data while creating a server manually is not very fast. It takes quite a while to do that. And I have experience with Terraform and stuff, so I'm looking forward to the more advanced projects. But that's it for now. Thanks very much, everyone.